Hello and welcome to Oplattery Videos, here to help you study, learn and succeed. Today's video is all about esters and condensation polymerisation. It's important to go back over esters because esters are what make the condensation polymers. It's kind of an advanced version of those equations. So we've got esters as our starting point, and then we're going to go on to condensation polymerisation. Okay, looks quite complicated. Let's take this a little bit at a time. So, first of all, just a thought about condensation. Condensation, well, we're used to seeing it kind of in this way. Little droplets of water on windows. So condensation simply means that we're going to get water produced. So we're expecting to see in our equation somewhere H2O. Polymerisation, well, we've got monomers making polymers. If we look at the words, they give us what we're doing. So a mono means one, poly, many. Mer simply means unit. So I've got one unit and then many units. A little bit easier to kind of think about what's going on if I think of it in that way. So condensation polymerisation is taking individual units, joining them together into long chains, producing water as we do it. It's kind of like popping beads. When you pop them together, you make your long chain from your small ones. So we're going to start with that forming of an ester because our esters are where this entire thing begins. So we're going to start with formation of an ester. Our esters are made from two things. They're made from a carboxylic acid and we react that with an alcohol. That will then give us our ester and the water that we were expecting. And water is made in an ester formation equation as well. So I'm going to start with ethanoic acid and ethanol, fairly common acids, fairly common alcohol. So our carboxylic acid, well, if I've got ethanoic acid, means eth 2 carbons in my chain. So there's my initial chain. To make a carboxylic acid, I've got to have double bond O, OH. That there being my carboxylic acid functional group. I then react it with an alcohol. So again, I'm saying I'm going to use ethanol, so I'm going to have 2 carbons in my chain. I'm purposely writing this in the opposite direction. The reason I'm writing it in the opposite direction, it makes the ester grouping easier to see. Okay, so I'm going to form an ester group at that point in time. What are the two parts that come together to form an ester group? Well, my two parts for an ester group, I've got to release water. If I'm releasing water, there's my hydrogen, there's my OH. If I take those two bits off, there's my water. That's where my water's formed from. I then follow this across and I'll get my ester. So if I start at this point, I've got a hydrogen, then a carbon with 2 hydrogens attached. My next bit is a carbon double bonded to an oxygen. Then I've got a bit of a bond. If I then come over here, I'm joining to an oxygen, to a carbon with 2 hydrogens attached, another carbon with 2 hydrogens attached, and lastly a hydrogen, plus the obligatory, as we've said, water. Well, we've got our ester, we've got our water produced, we've got to look for our ester functional group. Our ester functional group is this section in here. So that is what makes this an ester. In terms of our names, well, we've got ethanoic acid. We've then got ethanol. And we're making an ester from it. Now, ethanol, that's going to come first in my ester name. Ethanoic acid is going to come second. Although, because they're the same, it looks pretty easy. So I'm going to end up with ethyl from ethanol, and then from ethanoic acid, ethan. To show it's an ester, O8. So, ethyl ethanoate. Whenever we're writing these, the alcohol always produces the first part of the name, the acid produces the second part of the name. I know that's the opposite way round, but it makes this part a lot easier to do. So, there we go. Another example, let's try propanoic acid and ethanol. So if I have propanoic acid, meth, eth, prop, so that's 3 carbons in a row this time. 1, 2, 3. Again, I've got my carboxylic acid grouping. And then pop my hydrogens on. This propanoic acid. I'm going to react that with ethanol, so exactly the same as above. 2 carbons, meth, eth, therefore my ethanol group again. So, same thing is going to happen as before. I'm looking for combination of the name, there's my first part, there's my second part. I'm looking for my water being produced, so again, my water comes out there. So it gives me the same idea again. So this time I'm going to make ethyl propanoate. Okay, so I'm going to make ethyl propanoate. So if I draw this out, my ethyl propanoate. Again, it's following the same structure as before. So hydrogen, hydrogen, carbon with 2 hydrogens attached, carbon with 2 hydrogens attached, carbon double bonded to oxygen, bit of a bond, oxygen, carbon with 2 hydrogens attached, carbon with 2 hydrogens attached. First part of the name from the ethanol, so ethyl. Second part of the name from the acid, propan. Ester, A-T-E, propanoate. Okay, so ethyl propanoate. Again, my ester group. There we go, there's my ester functional group. So ethyl propanoate is my ester formed from that. Now, if we take this a little step further, so I'm just going to wriggle this up a little bit so you can see it. To make my polyester, I've got to have an carboxylic acid and an alcohol that have 2 functional groups, 1 at each end. So it's going to be a diacid, 2 acid functional groups, and a diol, 2 alcohol functional groups. It's going to look a little bit more complicated. Again, we can draw this out and we can make this look a lot simpler. So I'm going to start with my diacid. Okay, so that means it's got 2 acid groupings on it. So I've got HO like I've had before. Then I'm going to my carbon, my double bond oxygen. That is 1 functional group for a carboxylic acid. Again, I've got a second carboxylic acid functional group in there. So there we go. That's my diacid. Each carbon has got, as usual, 4 covalent bonds. 1, 2, 3, 4. This carbon, 1, 2, 3, 4. Okay, so I'm then going to add it to my diol. Okay, this one, an alcohol with 2 functional groups. So again, my functional group for the alcohol, same thing I'm looking at. So HO, and we're going to go into a carbon, I'm going to put another functional group on the end. Each carbon needs 4 covalent bonds, so 1, 2, 3, 4, 1, 2, 3, 4. We're going to have a hydrogen on each of these. When I'm joining polymers, if I say I've got a whole number of them, it's N lots of. Makes life a little bit easier for me. So where are my two, this time my two sections going to come from? So my first water, if we look here, I've got OH and H. There we go. There's my first molecule of water. My second molecule of water, because I've got two coming out this time, is going to come out. There's one part of it. There's the other part of it. Okay. This is then going to give me my polyester. So I'm going to get a poly, many esters. So polyester. So square brackets showing it's a polymer. There's part of my bond sticking out. So there. One carbon, double bonded to an oxygen. Go across, carbon, double bonded to an oxygen. And I join across again. There we go, there's my oxygen. Carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen, and I had an oxygen, and then my part bond. I've released two waters, 1, 2, plus 2NH2O. I've got as many of these as I had of those, and I'm looking for my ester grouping again. So my ester grouping, there we go. Ester grouping is the same in each instance, an ester grouping there, ester grouping there, ester grouping there. So you can see a polyester has this ester grouping in. The difference comes where I've got two functional groups, so I need two functional groups on each of these two. So two functional groups on both sides. So here I've got two carboxylic acids group. There we go, there's one, there's two. On this side a diol, 1, 2 alcohol groups. So esters and condensation polymerisation, as long as we work it through, forming an ester, make sure we get the names the right way round. First part comes from the alcohol, second part comes from the acid, giving me our name and further example, and then our polyesters, two functional groups, an acid and an alcohol, two functional groups on my acid, two functional groups on my alcohol, giving me again an ester grouping, opening up my bonds. This is where I then join more of them on. This is what we call, remember, a single repeat unit. So, esters and condensation polymerisation. Thank you for watching O Plattery videos, and I'll see you again soon.